Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss work power energy assignment number 20. Now here in your assignment number 20, let us see your first question. Your first question over here is a ball at rest is dropped from height 12 meters. It loses 25% of its kinetic energy on striking the ground and bounces back to a height h. The value of h is. Now when you want to find the value of h in this case, how do you find it out is? Let us try to solve it. In this case, the data which is given is actually a ball is there, and it is at a height from the ground reference. It is at what height? It is at 12 meters height. So the height over here is 12 meters. And now it just fell down, and after falling down it lost 25% of its kinetic energy. So 25% of kinetic energy is lost. That means how much is still remaining? So in 100%, 25% is lost. That means 75% is remaining. 75% of energy is remaining. Okay, is there. 75% is present. 75% of energy is there when it strikes this particular place. Now, so the energy which is present over there is nothing but at this particular point is 75 by 100 into mgh. Because actually at this particular point the energy over here is mgh, but after hitting here it lost 25% and remaining is 75%. So 75 into 100 is going to be left over, 75 into mgh is going to be there. So that is equals to, after hitting here it lost and it just rises to a certain height which is called as h dash. We will take it as h dash. I want this height. What is this height? The question mark over here is what is that height. Now if you want to equate that, then over here also, even here also, the energy over here which is called as h dash, you will have energy mgh dash, right? Your energy is going to be mgh dash. Now energy over here will be equal to the energy of there. So energy over here is 75 by 100. So 75 by 100 into mgh is equals to mgh dash. Now if you try to solve this, you can cancel this g are going to get cancelled, and what else will be left over here? You will be left over with 75 by 100 into h. How much is the h given over here? The total h is given as 12, so I'll write it as 12 is equals to h dash. Now I want h dash. From here, if you try to solve this, you are going to get 75 by 100. So 5. How much is 5? 1 is 5 is 15, 20. What is that? So you will be getting h dash is equals to 36 by 4. So 36 by 4 is how much? Nine. So your height is h dash is equals to 9 meters. Right? So your height after hitting this ground, that one has risen around 9 meters. Hope this is helpful for you. Let us go for next question. Now your second question is also going to be the same way of solution, and this is also a ball is at rest. It dropped freely from a height. Let us take the height. The starting point is height at the starting point is given like this. What is the height? First it is at 20 meters height. It is at 20 meters height. 20 meters height, and it lost 30%. It lost 30% of energy after hitting the ground. After hitting the ground, it lost 30%. That means how much is remaining? 70% is remaining. 70 by 100 into mgh is going to be the energy when it just hit this floor. And after that, it just rised. Actually, the height which it has fall down from is 20 meters. So h is equals to 20 meters. Now the energy starting over here is going to be mgh. Now after hitting it, just rise it to a height. I don't know what is that height, and I'm going to take it as h dash. Now anyway, energy at that particular point is going to be mgh dash. Now here I'm going to equate this one and this one again. So I'm going to equate mgh dash is equals to 70 by 100 into mg gets cancelled, h dash is left over. H dash is nothing but what is your h over here? 7 by 10, and your h is 20. H is given as 20. So 140 by 10. 0 gets cancelled. Your h dash is nothing but equal to 14 meters. So your height, the ball has raised after hitting and lost 30% of energy, and it raised back, and your answer, that means your height, to what height it has raised is, it has raised for 14 meters. Hope this is helpful for you. Let us go to the next question. Let us study about this third question. Now in this third question, the bob of a pendulum is released from a horizontal position if the length of the pendulum is 1.5 meter. What is the speed with which the bob arrives at the lowest point, given that it dispatched 5% of its initial energy against air resistance? Now when you want to talk about this kind of a question, you have to check out what energy is going to be present at when it is at a certain height. Energy at this particular height is going to be mgh. Actually, after that, at this low point, if it comes now, it is going to have kinetic energy, because at this particular point it is not going to have height, and at this particular point it is going to have height. So potential energy at this place and kinetic energy at this place. Now while coming to this place, let us take from A to B point. While coming to A to B point, it lost 5% of energy. Now when it lost 5% of energy, the remaining amount of energy over here is 95%. 95% of energy is present over here. When 95% of energy is present over here, then we will take the energy at this particular place would be energy at point A only. So 95 by 100 into mgh is going to be equal to half mv square, because the potential energy over there, when it comes to point B, it is going to get converted into kinetic energy. So we will take it as half mv square. Now from here, masses are going to get cancelled, and you will be having 95 by 100. So this is 95 by 100 into gravity, will take it as 10, and height they have given it as 1.5 meters. So the length of this pendulum is given as 1.5, so we are going to take height as 1.5, and that is equals to half v square. Now when you take this half v square, now let us see, if you cancel this, you will be having 95 by 10 into 1.5 into 1.5, and this 2 also comes this side, you will be having v square. Now when you try to solve this, you are going to get 9.5 into 3, 2 into 1.5, it is 3, is equals to v square. So v square is going to be equal to 28.5. Then v is going to be equal to root 28.5. So from here your V value is going to be equal to 5.323, so on, like that, meter per second. So your option is 5.28, sorry, 5.28, 5.3, somewhat around like that. So it is first option. Hope this is helpful for you. Let us go for next solution. Now coming to the last question over here, fourth question in your assignment number 20. In this question, a box of mass 50 kg is at rest and is pulled up an inclined plane of 12 meters long and 2 meters height by a constant force of 100 newtons. Now let us try to analyze this question. When you try to analyze this question, you will be getting that there is a body of mass 50 kg and it is pulled up an inclined plane. Inclined plane length is 12 meters. This is 12 meters length and it is at a certain height of 2 meters. This is 2 meters height. Okay, and this is 12 meters length. And you have an object of 50 kg. This is a 50 kg object, 50 kg object, and you are pushing it or you are pulling it up. You are pulling it up, pulling force. This is pulling it up. With what force you are pulling it? You are pulling it with 100 newtons of force. This is 100 newtons. Now when this box comes, that means 50 kg box, when it comes to this particular place, its velocity is given as 2 meter per second. So we'll take velocity as 2 meter per second. Now he is asking you then the work done when it is present at that last place. What is the work done over there? Again is the friction in joules he wants it. So work done against the friction. Now whenever you have a question like what is the work done is nothing but amount of energy which you spend on it. Okay, now how much amount of energy you have spent on it? How do you calculate it? You will calculate as work done is equals to half mv square. The energy which you spend on this particular body to move from this point to that point is half mv square. That is kinetic energy. Now what happens over here? W is equals to half. M is given as 50 kg. 50. What is your velocity given? 2 square, which is I am going to directly write it as 4. So 2 ones are 2 25s are 100. So work done is equals to 100 joules. So the work done again is the friction to reach to that particular point is 100 joules. So your option is 2. Hope this is helpful for you. Let us meet in next assignment. Until then, bye.